Okay, so we showed you how to take resistance readings and millivolt readings on the thermal pile side, which is what opens the burner coil. And now we're going to talk about the thermocouple side, which is what holds the pilot open, or the EPU, electromagnetic power unit, which is also commonly referred to and is your safety magnet. We have a very low voltage here generated by the thermal couple, somewhere around 22, 24 millivolts isolated while it's not doing any work, and we should hope to see somewhere in the neighborhood of 10 millivolts, 12 millivolts under load. This pilot is on and holding, so I'm just going to show an underload reading. An underload reading is going to tell us pretty much everything that we need to know, as long as we can get an underload reading. I would only take an isolated reading if the pilot will not hold. An isolated reading is a little more difficult to take, because with an isolated reading you have to isolate the thermocouple, which is threaded into the valve body here. The power then goes across either a blue or a brown wire, and it's soldered to what we call the EPU, or the electromagnetic power unit. Once that coil is energized with enough voltage, that allows you to release the magnet, or release the plunger that's holding the valve in the open position, and then the magnet will take over and hold that plunger open to allow gas to flow through to the pilot. I'm going to start with a continuity reading, and that's really all you can do with a multimeter like this one. There are resistance specifications on this coil. You would need a special 4-wire multimeter in order to take such a low reading. The resistance is so low that most multimeters, most 2-wire multimeters, will not give you an accurate resistance reading. So all you can do is check it. Do I have a circuit, continuity? Do I not have a circuit? Again, no circuit, no continuity, closed. I have a circuit, I should have continuity. So to check for at least continuity, what we can do is we can go from that solder point to ground, which is the valve body. So to do that, we'll go to the solder point and then hit the valve anywhere for ground, and sure enough, we have continuity. So now we're going to take a reading under load. We're going to measure the amount of power that is going through the electromagnetic power unit, or EPU circuit, while the valve is, or the pilot is on and holding. So to do that, we once again set our multimeter to voltage DC, and we're going to go from the solder point where the EPU wire is soldered to the valve, and then to the valve body. The minimum here, my numbers again, the minimum here is 8 millivolts. 10, 12 is kind of the magic number. 13, all should be well and good. But 8 is your absolute minimum. I'd really like to see somewhere in the neighborhood of 10. So again, to pick off that reading, we're going to go right to the solder point, which is one of the beauties of the SIT valve. Ground the other one out anywhere on the valve body. And as you can see, we actually have 10.3 millivolts, or in this case, negative 10 point, well, now 4 millivolts, or now 5 millivolts. Polarity on this does not matter. If I reversed my probes, I would get a positive reading. So as long as you have a digital meter, minus 10 is just as good as 10. So we have 10 millivolts. I mentioned earlier, if I could hold that steady, you'd get a steady reading. I mentioned earlier that we can't really take a resistance reading on this coil, but that doesn't mean we can't tell if this coil is healthy. This coil should require no more than about 4 millivolts for it to stay open. So we do what's called a dropout test. And a dropout test is very simple, because it's the same reading. We're measuring voltage, not resistance, but we're seeing where the coil drops out. In other words, where it's going to no longer hold the pilot open. And it's a very, very easy reading to take as well. What we do is we put our multimeter on those same 2 points, because we're measuring voltage, or millivoltage in this point. In this case, it's just below a volt. Anything below a volt, we talk about it as being a millivoltage, or a decimal fraction. So to take this reading, what we want to do is we want to be on the EPU and to ground, measuring voltage. We want to shut off our heat source, because that's how a thermal generator works, right? You have a hot end and a cool end, and for whatever reason, that temperature differential between the heated end and the cool end, that generates millivoltage, or a small amount of electricity. So we eliminate our heat source, we measure our voltage, and we have to listen for our click. And that should click somewhere between the neighborhood. Again, these are my numbers that I've come to over the years to feel comfortable with. Somewhere between 5 and 2 millivolts. If we drop out below 2 millivolts, that's fine, that's wonderful. But if we drop out above 5, what that tells us is that there's too much resistance in that circuit. It should not drop out above 5 millivolts. It should really be somewhere down around 2 millivolts. So let's see what we have here. I'm actually going to shut it off first. We saw we had well over 10 volts, millivolts there. I'm going to shut it off first so that I can come around and get a good reading on the thermocouple under load. So I shut it off. Coming around back here, I'm going to take my millivolt reading, which again is going to be negative because of the way I have this hooked up. 5. Watch it drop and listen. Clicked out at 2.4, so that's right in spec. Like I said, if it were slightly below 2, that would be fine. Above 5, what that would indicate was that we have too much resistance in that tiny coil, and if we're having nuisance pilot outages, chances are that's the case, because it's dropping out too soon. Gust of wind, anything like that, if it's running at 10, say it's running at 8 millivolts and it drops out at 6, there's not enough cushion there for it to run reliably or consistently for any real period of time. Like I said, 8's the minimum, 10's kind of the magic number, and it should drop out somewhere in the neighborhood of 5 and 2. So that pretty much completes how to take resistance and millivolt readings, continuity readings on the SID 820 system. Do remember that on the pilot on demand valve, polarity is going to make a difference on the thermal pile, and they may or may not be labeled correctly. Most of the time you can count on red being positive, which should be on the TPTH or lower terminal, and white being negative, which should be on the TP terminal. I hope that's helpful, and until next time.